Hi guys, this is Miss Hart-Townsley, and I'm going to just show you a brief tutorial here on lesson 3.04. I've had a lot of people submitting their quizzes, and it looks like we're having some issues setting up our Punnett squares. I have a feeling it has to do with some of the material in the lesson, so I'm going to go over that with you. If you look at the objectives right here on the last page, it says that you need to be able to describe monohybrid and dihybrid crosses, and also explain how heredity can be illustrated mathematically. Not all crosses that occur are going to be monohybrid or dihybrid. So for example, and I'm going to pull up the boogie board over here so you guys can see, for example, sometimes we don't have two hybrids for the trait, right? So for example, sorry, I've said that 3 times. If I have a brown, and let's say brown and black fur with what was the other? We have long and short fur. Okay. Now a dihybrid would mean I would have two parents that were hybrid for each one of these traits. Okay. We'll say that brown is dominant. We'll say that black is recessive. Long is dominant and short is recessive. All right. So a dihybrid would look like this. Okay. So we're a hybrid for both traits. Both parents are hybrid for both traits. So I have one dominant, one recessive, one dominant, one recessive, and same over here. All right, those problems on our practice test aren't necessarily dihybrid crosses though. In one instance, they might have a homozygous dominant brown, long-furred organism. Okay, so I'm homozygous dominant for color, but I'm a heterozygote for length. And I cross that with a homozygous recessive for color and homozygous dominant for length. Right? Those are two very different genotypes, and they're going to produce very different crosses. And I think that's where we're getting mixed up. Right? The dihybrid is real easy. I think you guys understand the gamete formation. Right? But I like to call it the foil method, even though it's not technically foiling. But what we want to do is look at all the possible combinations that we can get. So for example, I know that in this case I could get a dominant for both traits. I could get a dominant for one for color and recessive for length. But then if I go here to this, I get a dominant for both and dominant recessive. And so I actually only have two combinations of gametes for that organism. Those are the only two combinations that that organism can donate to the next generation. Right? Same thing if I go over here, I'm going to go little b, I can have a recessive and a dominant, recessive and a dominant, recessive and a dominant, recessive and a dominant. Alright, so the only combination I can have here is recessive and dominant. That's the only thing the parent can give. So my square or my mathematical model here, this parent, let's say it's the mom, she can only donate one gamete type. Let's say the father, on the other hand, can donate a dominant of both or a heterozygote. And so I actually only have a Punnett square that's a 1 by 2. And when I put these together, big B, big L, big L, big B, big L, little l. Those are the only combinations for my offspring. So when I'm doing the ratios, if I look at the genotypic ratio, I've got a 1-to-1 dominant for both. Okay, so big B, big L, and 1, big B, little b. Okay, when I look at phenotype, I know I've got 100% brown and long. Okay, and so like I said, what's happening is we're setting every cross up like a dihybrid cross, when in fact there's you have to determine the gamete possibilities first. Okay, I hope this helps a little bit. If you have any questions, please let me know.